question 4, we have a cos x and a cos squared x. This makes it a quadratic equation. So if I have a quadratic equation, I can solve that with factoring or the quadratic formula. But first, I have to always make one side equal to 0. So I'm going to move everything over to the left. And I'm going to write the cos squared first. Me personally, when I'm choosing which side I'm going to move things to, the left side or the right side, I like to have whatever's in front of my squared as a positive coefficient. It makes factoring easier. It makes the quadratic formula a little bit easier. So I'm going to move everything over to the left. 3 cos squared x plus cos x minus 1. And now you have an option. Should I try to factor it or should I use the quadratic formula? Okay. If we tried to factor it, we'd find out it doesn't factor. Or if you're trying to factor it, even if it can be factored and you're trying to factor it and it's not working for you, the quadratic formula will work always. So if you're like, ooh, I'm not good at factoring these ones, maybe I want to use the quadratic formula. Perfect. So quadratic formula, it's cos squared, so we have to write cos x equals negative b plus or minus b squared, which would be 1, minus 4 times a times c, all over 2a. And I'm going to simplify this. Cos x equals negative 1 plus or minus the square root of 13 over 6. Which splits us up. I'll do 1 with the plus sign. And 1 with the minus sign. And I'm going to change both of these to decimals for 2 reasons. 1, if I change it to a decimal, it'll tell me if it's positive or negative. So I've got negative 1 plus the square root of 13 all over 6. And I had negative 1 minus the square root of 13 all over 6. Retype that one in so I can see it again. 0.434 for the positive one. And cos x for the negative one was equal to negative 0.767. Just go dot, dot, dot. I'm not rounding early. Even though that rounds to 8, if I put the dot, 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 it just means I'm keeping all of those decimal places all the way through. And that one was negative, right?
Yeah.
So 2 things this helps me. By changing this, I know the one on the left is positive, the one on the right is negative. I was really hopeful that something would happen that would make our life easier. But it wasn't, didn't it? If one of those was bigger than 1, sine x and cos x, you can't have a hypotenuse smaller than the adjacent or opposite side. So any number bigger than 1 is like, woohoo, not possible, and you're done that side, and you don't have to do any more work. Oh, can you imagine? You're like, you see one of these questions, and you're like, oh no, because everybody loves the quadratic formula ones, right? You're like, oh, I have to do quadratic formula. And you do the quadratic formula, and both sides are bigger than 1, and you can just write not possible, and you're done the question right like that. Feels a little weird, though, if a question, the final answer is all not possible. Do you feel like you might have done something wrong? Maybe? Yeah, that's not, those not possible answers Oh, I did all this work only to find out there's no answer. I must have done something wrong. But sometimes that happens. Okay. Makes me think I should put one like that on one of your take-home quizzes. This side, we need to find our reference angle. So we do cos inverse of 0.434. Go to my calculator. Second, cos inverse. Oh, I'm in degrees. Is this one in degrees? No, it's in radians. So I have to first hit my mode button and go back to radians. The newest calculators are nice because they say it at the top. Some of the older versions, you still have to hit your mode button to check. So I'm going to go second, cos inverse of the positive one here, 0.434. And my reference angle is 1.121 ... The nice thing about doing the ... is you actually don't have to round. You're saying that you've kept all of your answers. Now cos is positive. In quadrant 1, there I'm writing my final answer, so there I'll round it to 1.122. And in quadrant 4, so I'd go back to my angle here, and I would go 2 pi minus my reference angle, 5.162. And I'll do the same thing on the other side. And find my reference angle for the other side by doing cos inverse of. Now if I go up and select this value, what's the problem? Is there's the negative. This time I'm going to spend all the time to go back and delete it. Push enter. 0.696. Reference angle 0.696 for 3 decimal places. And since it's negative, we would be looking in quadrants 2 and quadrants 3. So I know I'm going to use this twice. So I'm going to use my store button, store it as x. Quadrant 2, pi minus x. And quadrant 3, pi plus x. So 2.446. And 3.837. And again, I'm going to make a note that both of these were solutions between 0 and 2 pi. I sort of make it a habit that I go once around the circle and find all my answers between 0 and 2 pi. And then I hope to make that happy face again to read the question and say, that's exactly what they said. Am I going to be happy? No, I'm not? Oh, no. Oh. Right? Over negative pi to pi. So, let's think about negative pi to pi. Do you see that those are positives from 0 to pi and negatives from 0 to negative pi? From a picture-wise, that would look like 0 to pi. I'm looking at these ones, and I'm looking at these ones. Okay. Some of mine are good. Some I'm going to have to change, right? Like, this one was in quadrant 1, and this one was in quadrant 2. Those two would be fine. But this answer was quadrant 4. Oh. I've got to either do Roman numerals or regular numbers. Shouldn't mix back and forth. And that one's in quadrant 3. So my final answers, which I'm going to circle right here, x is equal to, I can keep the 1.122. I can keep the 2.446. I need to change the quadrant 4 one to a negative angle. If my reference angle is 1.122, this will be negative 1.122. And if I want to go to quadrant 3 in the negative direction, do you see that that's the same distance as quadrant 2, but in the negative direction? So I could just take my quadrant 2 answer and make it negative. Or I could take that quadrant 3, 3.837. Let's do that on our calculator. I could take my answer and subtract 2 pi, because if I subtract 2 pi, that will be coterminal, and you'll see that you get the negative 2.446 answer that way as well. So you want to find something coterminal, you can always add or subtract 2 pi as many times as you want. So again, these ideas of coterminal and solving stuff, that's also in chapter 6. In fact, everything that we did in part A in this one is a review of chapter 6. What's new is part B. Part B says, determine the general solution. Oh, and then I just read this. Really? So, do I need this extra 2? No. Do I need, this one will make this 2.45. Don't need that extra 2, and this is negative 2.45. There we go. Struggled a little bit with the rounding. But it shows you that there's so many little details that they're looking for. So you do something and read it over to check for those little details. And now in part B, it says to do the general solution. And for the general solution, that's why I like to solve it between 0 and 2 pi. I'm going to take all those answers that I got between 0 and 2 pi. 1.12, 2.45. What's the next one? 5.1, no, 3.84. And 5.6, 5.16. Add 2k pi to each of them. If you're on your provincial exam, and you had a question that was general solution, but for whatever reason you forgot how to solve it completely, you could leave your whole question blank and get 0. That is an option. But if you remember that the general solution is whatever answers you get, you have to add 2k pi where k is an integer, you could make up math and get some answers that are completely wrong. But then if you take your completely wrong answers and show that you know what to do with the general solution, they'll still give you that last mark, which is way better than leaving the whole question blank. So the exam is, and the course is nice that way, that they allot marks for different ideas in the question. So even if you don't know the beginning idea, you might know the end idea, still show that part, because you might get that mark. Okay, and questions for this one are 12, 13, and 14. Some of them you have to use a quadratic formula, some of them you can factor.